I hope we're live now. I pray to God we're live. We better be live. Oh, my days. I used to pray for times like these. Oh, my God. Alright. Yep, we can hear you, mate. Alright, yeah, I'm just talking to myself right now, so hopefully we'll get some people joining us. But yeah. IMO 2026. IMO 2026. Someone in chat said, nah. Yeah, I mean, I guess, bro. I guess. Nah. But alright. Alright. We're so back. And nah, not talking to yourself. Oh, I love you, mate. Yeah, I'm talking to you. Abhigyan Shri. How are you? Where do you get the problems from? Okay, we're back. We're back. I only got P1. Well, as it happens, I have all the problems right here. Yeah, problem 1, problem 2, problem 3. So, this is taken from the IMO, Syria 3, the third contestant of the Syria team. And yeah, without wasting your time anymore, let's do it. Okay, let me know if it gets too quiet. If it gets too quiet, I'll just hold this and talk. But let me know if you can still hear me okay. But yeah, problem 1. This is a number theory question, and number theory is my personal strong suit. So, we need to solve this pretty quickly, especially like geometry, and geometry is hard for me, and question 3 is always question 3. So, yeah, let's do it. We have 2026 integers greater than 1 written on a blackboard. And hold on. Alright, cool. 2026 integers greater than 1 written on a blackboard. And in a move, Confucius, because they make it China themed, Confucius chooses 2 integers, m and n, different place on the blackboard, and replaces them with GCD mn and LCM mn over GCD mn. He continues to make moves until he can't anymore. And proved that, regardless of the choices of Confucius, after finitely many moves, exactly 1 integer m on the blackboard is greater than 1. Okay, so I guess we can see, basically it wants us to prove that eventually almost all the integers on the blackboard become 1. Right. So I guess it makes sense to see why that's true, because we know that, I'll go to the whiteboard now, we know that GCD, that's not too bad actually, GCD mn is less than or equal to the minimum of mn. And equality only holds if, so let's say that m is less than n, less than or equal to n, these two can only be equal when m divides n. So yeah, I noticed that like when you replace 2 integers, you're essentially swapping 1 integer with one of the one of the options we have there. So, yeah, so essentially, like, I can replace m with either one of these and n with the other one. So let's say that if m is the smaller one, let's say we replace it with GCD n, and if n is the bigger one, let's say we do it with LCM over GCD. Now the nice thing here is that this smaller one almost always decreases. And if it doesn't decrease, then it means that m divides n, so n equals km, and the LCM over GCD becomes k, which is less than km, unless m equals 1, but we are given that m is more than 1. So basically, whenever we make a move, one of the numbers gets smaller. Hang on. Yeah, so either the smaller number gets smaller, or if it stays the same, implies that the larger one gets smaller. And yeah, so we can do a sort of argument where we have the numbers in order, the 2026 numbers, and yeah, the smaller one goes to 1, then that one, pretty much. And yeah, there's probably a slight detail where if you have the smaller one divides everything that it doesn't move with. So if the smallest one, divides like x2, x3, all the way up to x 2026, then this only holds finitely many times because the smallest one never decreases, and x2, every time it makes a move, always decreases. Because it decreases when it moves with x1, and since it's the smaller one out of x3 to x 2026, it decreases there as well. All right. Let's check chat for a bit. Bro, you gave IMO as Indian or from other country? So I'm from UK, and I haven't been to the IMO yet. You are in which grade? I'm entering my last year of school right now. But yeah, so that's part A done, 1A. And yeah, let's find some more space. Move on to 1B, which is prove that the value of m does not depend on the choices of Confucius. So essentially, like, we always end up with the same final value with a bunch of ones, no matter like the order of moves that we do. And yeah, so maybe this is like maybe a good thing to show maybe is like if you have two moves A, B, and then so if you do a move on A, B, and then you do a move on like B, C, you can do a move on B, C, and A, B. And so if you do it in this order, you can also do it in this order and get the same outcome. Because because you don't actually know which moves are being done. So this method would work if we knew, like, if you knew the moves that were being done. But we haven't proved that there's a specific order to the moves, so we can't use this method of like swapping. Okay. I didn't want to pull this out because I thought it was just IMO question 1, but yeah, I think we might have to use a very important trick. Does this thing give you tension that this is the last year and the last attempt? Yeah, kinda, because I know that if I miss this one, then all these years of work go to nothing. But positive mindset, and if you lock in, I believe that if you work hard for something, it will pay off in some way or the other. So even if I don't, I've still learned a lot. I made some amazing friends, and it's been a great journey. But yeah, okay. So we can't do the swapping moves. And what I was gonna do was there's a trick when you have GCD, GCD MN and LCM MN, which is you consider the exponents in the prime factorizations of M and N. The GCD, so if you have primes, let's say you got a bunch of primes that divide one of M and N. The GCD is if you look at the exponents in each of the prime factorizations, so let's say this is M and this is N, the GCD is just taking the minimum. So for each prime, you take the minimum out of alpha I and beta I, and the LCM is taking the maximum. Alpha I and beta I. So I'm thinking if we rewrite the problem in a way that looks at the exponents of each prime factorization, we can solve it. So yeah, GCD becomes so right now we have one blackboard, but let's say there are L primes dividing the product of all of the numbers. So L primes that divide at least one of the 2026 numbers. Then we have L different blackboards. So this is what our game is equivalent to. And on each blackboard, we play a different game. Right. And the game we play is we take. So yeah, if we have two numbers A, B, then GCD, so let's say A and B are like exponents in the prime factorization, then GCD would be minimum of A and B, and LCM over GCD becomes max AB minus min AB. So if this is true, then it becomes A and B minus A from A and B. Okay, and we want to show that the result of each of the games on the blackboard only depends on the starting number. Let's check Chad. What is your motive as for giving the Olympiad to go to a top US school like Harvard or MIT? I assume you ask why I do it. Yeah, I do it because I like it. There's nothing special there. Do I have a work or public email? No, but I should probably make one, so I'll post about that. Can you recommend any good resources for learning and practicing proofwriting? I'll make a video on that, don't worry. So, yeah, we want to show that the result of the min-max game turns out to be the same on each board. And so I don't see why that's true, honestly. So let's just play the game. We start with 1. Then our claim is that the order doesn't matter, so obviously 1, 4, we can make that 1, 1 eventually, and then 1, 6 can make that 1, 1, 1, and this becomes 0, 0, 1. But if we had like 2, 4, 6, then that would become 0, 0, 2. So yeah, it seems seems like a GCD type thing is going on, because if you have like 237, then you get 127, and then you do the stuff with the 1 to get a 001. So I think the final number, come on, give me some space, give me some space. The final number is the GCD of all of our starting exponents in the min-max game. And yeah, we can induct on that. The base case would be 0,0,0,0 n. So we can induct on the sum of AI. And if you have any config AI A2 up to A2026, then doing a move with two, then doing a move, you keep one of them the same. So remember, you get AB to A and B minus A, and the GCD of the numbers is left unchanged, and this is just Bezoot. Yeah, so all we need is GCD XY equals GCD X Y minus X, and this is like very well known. This is this is a fundamental property of GCDs. So yeah, the exponent. So like if you play the game with the exponents of each prime in the prime factorization, then we get the same result. So combining into our original game, we get a fixed result. So it doesn't matter what Confucius does, we get the same number. That's very nice. Honestly, IMO question ones since 2023, like 2023, 2024, 2025, they've all been like super easy. So yeah, it's nice to see a actual IMO question 1 difficulty back again. But yeah, now we try question 2, and yep. But I'll take a break and see what you guys have posted. You are in Shanghai, China? No, I'm not. That's why I'm live streaming this. I'm not in Shanghai, China. Yo, when did you start praying for IMO? And like any advice for the ones who wish to participate as well? So yeah, I mentioned in my video, I started preparing when I was 12. And don't worry, I'm making a bunch of videos on how to prepare, how to get better. So yeah, stay tuned for that. Yeah. Devil aspect. Yeah, you nailed it. I started when I was 12. I love Geo the most. I hate Geo the most. So, we'll see how question 2 goes. Do you have so you're gonna see how I deal with weaker topics, because Geo is my weakest topic, and this question doesn't look easy. But I think a good mindset to have when you're dealing with questions you find difficult is you just gotta believe you're gonna solve it, right? There's no point trying a question a little scared like a coward, oh, it's too hard for me, I'm not gonna solve it, because you'll make no progress. But if you believe you're gonna solve it, then you approach the question with a good mindset. And because Maths Olympiad is like, it's all up here. You're thinking. You're using your brain. So if you make your brain feel good, make your brain feel confident, then you're gonna do better. So yeah. And that being said, let's do question 2 now. So ABC be a triangle. Good thing. Do you want to draw the circumcircle of ABC? Yeah, why not? Let's do it. So yeah, guys, always rename the points. If I can do that. Yo. Gang. Hold on. Yeah, I can't lie. So you've been avoiding CG a lot just because I'm not as great at them. That's you probably heard this one before, but that's exactly why you should practice them. So yeah, practice your weak points, and yeah. So I'm gonna mark the center of the circle. So O is not the center of ABC. It's inconvenient, very inconvenient. So I'm gonna mark this as like Z. That's so tapped. That's so tapped. What? Okay, if I mark it as Z, put that as A. B, C. Okay, call that B. Right. Well. Okay, and we got segments. And we need to add the midpoints. Ay, ay, ay. Do you see a midpoint anywhere? Construct midpoint. There we go. So we want the midpoint of AB to be M, which I can rename, hopefully. And we want the midpoint of AC to be N. So I can do that as well. Right. Let points K and L be chosen strictly inside triangles BMC BMC and B. What this? What is this condition, man? Such that K lies strictly in. It's probably to avoid Yeah, guys, don't be phased by weird conditions. It's weird. The weirder the condition, the simpler the problem is. Remember that. That's a bar. See, like question 3, you can see there's not much going on there, which is why you know it's hard. But there's so much going on in question 2, so it's probably not that hard. Triangles BMC and BNC. So they meet at the centroid. Nice thing about GeoGebra, which probably makes this easier than doing it in contests, is you can move it around, make it nice. So I didn't want the circumcenter to be on, like the triangle we had earlier was pretty close to being isosceles, and the more you do geometry, the more you realize that when things are isosceles, that's when shit goes crazy. So, yeah. Let's see. Does IMO 2025 SLR get released? They get released tomorrow. So I might make some videos on the questions. We got some nice questions in the TSTs. And yeah. That's enough said about that. You are doing a great job. Yeah, we'll see if I can solve this. If not, then you know. But okay. So start K lies strictly inside ABL. So first of all, K lies inside BMC and it lies inside ABL. So maybe if we choose K here, my weakest topic is geometry. Which is good timing. It's very good timing. So if we choose K here, then we need so maybe we could choose L to be there. See, just use that these points are so oh no, but they have conditions. KBA. So KBA. It's a nice thing again, which in a contest, you want to draw multiple diagrams. And yeah, some of you may know a guy out of Olympiad Mathematics, my friend. He gave me a good advice, which was, you want to draw lots of freehand diagrams, because let's say you do a compass diagram and then you mess it up, you have to start all over again. But a freehand, if it's wrong, you can quickly draw another one, and you know you go off your intuition rather than trying to pinpoint stuff on the diagram. So that's something I want to share with you guys. If I find an alternative solution, yeah, you can share it in chat after I solve it, because I don't want to get spoiled. I want to see how much I would have gotten in the IMO. But yeah. So hold on. Just play the stream on mute. Okay. It's hard to recognize. Yeah, that's true. But you gotta just practice on easier questions with a freehand diagram, and you will get used to spotting observations and stuff. What's your strongest subject? Number theory. And so it got wasted on question 1. I was hoping for number theory question 3, but in life you don't always get what you want. Okay. I'm getting sidetracked way too much. Angle KBA. So angle KBA equals angle ACL. So this angle is equal to this angle, which means if we extend it, so this is a config. It's yeah, that's all there is to it. If we extend it, mark these points. I should also probably change that to, so the one on the one inside BNC is L. So I'll be changing that to L, and I'll be changing that to K. Okay. So then obviously this BCFG we have is a cyclic quadrilateral. That's very nice. And I'm going to make the extended lines go away for the time being. We might need them, who knows. But for now, we don't. So yeah. Hello, bro. I'm a big fan. Thank you. Hello to you too. Right. We have some more angle conditions as well. Bro, you were selected IMO from your No, I wasn't. No. That's why we're here. Yep. Okay. LBK equals LNC. So LBK equals LNC. Yeah, that's kind of crazy to interpret actually. LBK equals, and I assume the other one's a similar condition. Yeah, BMK equals LCK. Thank you. Well, we'll see how well I do on this. What's your mindset when you solve these problems? Well, you gotta go in thinking you're gonna solve it, and just give it your best shot. Try stuff if nothing you tried has been working, then try other stuff. Make sure you're always trying something. And yeah, so right now we got some floating points, K and L. And what I'm trying to do right now is characterize them in nicer ways. So already we have that they are on the diagonals of a cyclic quadrilateral. It's B, C, F, G. My days. Then we have the circumcenter of AKL, which is pretty wild. That's no, that's not. You want circled through 3 points like this. Okay. Hi. And yeah, so we had some good stuff. No, we didn't have any good stuff. Sorry. LBK equals LNC. Maybe there's some spiral similarity going on. I don't know. Or yeah, I don't know what's going on with this. I'm gonna be so real. This seems pretty hard. We've got okay. We can. Is there a text on GeoGebra? This is how you know I don't do much geometry. Is there a text? There is text. So we've got BCFG cyclic. That could be huge. And we want to find. Come on. We want to find some. My days. BCFG is cyclic. That is true. We know that. Who do you think got a best score in UK team? Well, that's a pretty easy one if you know the UK team. Yeah, I'm not gonna answer that because I'll just let you know we have on the UK team we have someone who is the best Olympiad mathematician of all time, and I reckon he got the best score. But yeah, I don't know. I'm thinking, is it a method to try question 3? But then again, like question 3 looks really hard. Yeah. You knew about him. I'm a Hall of Fame. That's right. So yeah, it's just this one angle condition that I can't interpret. Well, 2, but they're symmetric. That's another observation. L and K are pretty much symmetric in this problem. And we want to try and figure out what it means for LNC to equal LBK. So maybe, is there a pen or something? So you want that, these two things are equal. Like this diagram is bonds, by the way. There's no way this diagram is correct. Is there another cyclic quad hiding here? I don't even know, man. Damn. Yeah, so again, we want to make sense of the condition LBK equals LNC. Anyone got anything? I'm joking, I'm not. I can't do that. We are solving this for real. Isn't it difficult to make accurate diagrams in the exam? Yeah, especially for this question. Which is why you know you don't want to do an accurate diagram. Hey, no way. What's up, Matho4269 Mixty? That's a That's a Bonds username, by the way. But good to see you. I think we should use the fact that M and N are midpoints. I think that's gonna come in because we have a cyclic quadrilateral. So wait, so because we have a cyclic, so that's anti-parallel, and maybe it just so happens that MN. So yeah, because MN is parallel to BC, so MN is like basically MNFG is a cyclic quadrilateral as well. So, bro, this geo slimed everyone for IMO. Well, I'm not at the IMO, so it's not gonna slime me out. But yeah. It's just that one angle condition makes no sense at all. Oh, slime V3 too. That's right. That's right. Thoughts on ISI/CMI? What CMI is Chennai Maths Institute, isn't it? Have I solved P6 of last year? No, I haven't. Okay. Gang, it's just okay. So BCFG cyclic, MNFG cyclic. Who are you? Ooh, yeah. Who am I? That's a great question, lad. Where are the problems? Yeah, I went to China, took a Syrian IMO guy hostage, and got the questions. So yeah, take a screenshot. Oh my days! But this is grim. This is dark days. Maybe extend this. So yeah, we can then get this angle related to this angle. What? We want to force a cyclic quadrilateral somehow. Okay, that's the plan. That's the plan. Force a cyclic, and okay, yeah, that's another. If you extend that line, you and if you extend this line, in my opinion, day one 2026 is harder than day one 2025. Yeah, I mean, I think 2025 day one is probably the easiest IMO day of all time. So I'm not surprised by that, to be honest. So yeah, so many. Oh my god, Mashi, I'm getting a migraine, gang. I can't do that many lines. I'm sorry, I can't. So okay. Man, you got great facilities. Yeah, GeoGebra. You should probably start using it. Hello, hello. Um, yeah. Like, wow. Oh my days, this is so dark. How far are we in? We're like 45 minutes in, I think. It's not even been that long, but it feels like ages. How is it in British team? How is it in British team? I'm not in the team. I'm in the squad. So those are like two different things. And yeah, the British team, I think this year especially, were very good. We've got a very, very strong team, and I hope we do well. I'ma get some paper because I need some paper for this. Okay. So I wish I could show you guys, but I'm gonna draw a quick freehand sketch right now. How many have you solved? So we've done question 1 and we're doing question 2. How'd they do today? I actually don't know. I'll find out after the stream, I guess. And how to improve geometry, that's what... You know what? How to improve geometry, now that... I don't know if you guys know who this is, but a guy called Anand Mudgal came to the UK and he gave us a talk on how to do geometry, which I only remembered it just now, but essentially you want to split it into two things. Like you want to split it into the charging phase, he called it, which is making observations, and you want to split it into so charging is making observations going forwards, conjuring is starting from the end and working backwards. And charging, the main thing is like wishful thinking, you know, you want to add nice points and whatever. Yeah. Mikhailo Stadenko, yeah, I know him, proposer of this, said that this problem must be P3. Right, thanks. Oh my god. Yeah, this is, if that's true, this is a very hard IMO if that's true. But we'll see if that's true. If I can solve it, it's definitely not meant to be P3. So, okay. M, N, and draw those triangles. Choose a point K up here, like that. Choose a point L, just like that. That's my freehand. And okay. Holy Oralos. Yep, so LBK equals, oh my days. I'm just saying the same thing over and over again. LBK equals LNC and KB LBK. Oh wait. So I'm feeling like LBK equals LNC. Okay. Can you show the problem for a sec? Sure. Yep, here it is. Apply homosity with center A. Gang, like, can we not go around doing that, please? Right, I might close up the chat for a while. Just give me a sec. YouTube. Alright. So, okay. We extended the sides because KBA equals ACL to get F here and G here. Also, you can let this be and L. Okay, so this is what we got right now. Freehand diagram. And yeah. Okay. Hi. What is the time right now? 11:36. I don't usually sit still doing this as well. I usually, in the tests, UK guys can vouch, I'm usually the guy walking around the back, but, you know, it's good practice for eventually when the IMO comes, if it comes. So yeah, we said BCFG is cyclic, as we wrote down. And, yeah. Man. Tough problem. Tough problem. Oh yeah, and of course the circumcenter. Right. Open up the stream. What are y'all saying? Please answer my question too. Yeah, sorry, I missed it. What resource did you use? I'm making a video. Yeah, that's most questions you guys will ask. I'm probably making a video for that, so don't worry. But yeah, man, are you 16 for real? Yes, I'm 16 for real. Yeah, I am. No, sorry. What am I saying? I was 16 when I started making the video. Now I'm 17. Like making the big journey to the international whatever. But now I'm 17. Physics? I don't do physics. You sound like 22. That. Thank you. Thank you. So it's my last year, yeah. Next year is my last year. You're right. But meet you next year at IMO. A lot of love for India, mate. Thank you guys. Thank you. Yeah, which university are you going for your undergrad? Offers come out next year, so I'll see. And yeah, gang, I'm gonna just pretend I didn't see that brain smart. I didn't read it. But yeah, wow, that looks useful. How do you deal with the angle condition? That's what I want to know. I'm not asking you guys. Don't type out in chat. Don't type out. But I need to figure out how to deal with that weird angle condition. Because I feel like there are some cyclics hidden. Once we get all the cyclics, put them together, bang, that's the problem. Let's check chat. Will you maths is a subject? Yes. Are you a gap year student or a high school senior? I'm a high school senior, I guess. Yeah. That's right. Okay. How do I see the stream? Like, I want to see the stream, but not the chat. How do I do that? I don't know. Anyways, doesn't matter. Just look at both. Man, which software do you use to edit? CapCut. CapCut free is all you need. Literally. Don't even need the pro. Bro, you visit India? Yeah, of course I do. I'm coming there pretty soon actually, so looking forward to that. Damn, this question is actually hard, man. Oh my days. Getting my boy's in chat was right. It slimed out everyone. You have damn nice edit, man. Thank you. Which state? You can probably guess from my name. Did I do P1? Yeah, we did P1 earlier in the stream. Oh my god. So, it's been at least like 40 minutes in this question. All we have is one cyclic quadrilateral. That's right. Facts, swag boys. That's right on the money. What's up, CLS Goat? How is Step? Yo, that's crazy, but no, I didn't actually do. I'm doing Step next year, so I don't know is the answer to that. So P1 in just 15 minutes? Yeah, I think so. Yeah, I was explaining all that, but yeah, I think it was 15 minutes. Do I think Team AI will beat Team China this year? Honestly, I don't know. Question three is combinatorics. Even question one is kind of compy. And question two, we'll see. I reckon AI can probably solve question two, which means AI might be better than me. So yeah, I gotta solve question two to prove I'm better than AI. That's what we have here. Bro could have easily done it early. I don't think so. Prepared for IMO, yeah, all self-study. What are your predictions for day two? See, I hope we get a P6NT, but I think that it's been a while since there's been a Geo P6. So I think it'll probably be Geo, unfortunately. Yeah, Dr. Diggy! Yeah, we love Diggy. Yeah, let's go back up on the stream. Alright. So, okay. Right. Well, okay. So yeah, what we had was, I've said the same thing like, gang, this question is hard, man. This question is hard. BMK is equal to LCK. So that is equal to that. BMK equal to LCK. I might draw in the thing. Yeah, we've already drawn it there multiple times. Yeah. Maths is hard, man. Like, I'm gonna be so real with you guys. Maths Olympiads is like very hard. Okay. Right, so because of parallel lines, we want to use the parallel lines, remember? This is equal to that. Yeah, that's equal to that. Which, are we getting somewhere? No, we're not. Yeah. 1150, that's so dark. Check in chat. Can you explain the problem statement again? Yeah, sure, that might actually help me as well. So, if we have ABC, it's a triangle, you mark the midpoints, and mark the midpoints of AB and AC, respectively. We have some random points KL that satisfy these angle conditions, and we want to prove that if you have the circumcenter of AKL, OM equals ON. Will you ever be able to sleep? At this rate, probably not, man. Like, oh, this is hard. Oh, my days. Man. Okay. Fine. Right. Okay. So right, okay, we can do something here. I think BGF is 1, come on, let's write neatly. 180 minus C. That's a start. That's ay. That's a start. Okay. We're getting somewhere. I don't know, man. I don't know. All right. Angle conditions. God damn, why couldn't Geo be P1, honestly? There was no need. Still waiting on the Rade edit. Oh my god. Oh my god, still waiting on the Rade edit. Yeah. One day, man. One day. Oh, that's funny. But yeah. Okay. Lock in. Lock in. Close up the live stream. Let's do it. Na 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 na. Do 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 do. Do 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 do. So that's BL extended. So that, say that equals that. Yep. And yeah. Okay. What even is going on? What? Oh. Thank you, bro. Thank you. How do you go about drawing diagrams in an actual contest where you don't have GeoGebra? You just do a compass, and no, I don't think you can't take a notebook to the contest. At least we couldn't in TSTs, RMM. Maybe IMO is different. I don't know. My days. If only Geo wasn't P2, man. Like, Geo P3, at least I have an excuse, but this is unforgivable. I gotta get 2 questions today, guys. That's the aim. You got any favorite math Olympiad YouTubers or teachers? Well, I think I'm pretty good. All serious though, Art of Olympiad Maths, Art of Olympiad Mathematics. That's a very good channel. He's very good at geometry as well, so maybe I should watch some of his videos. But yeah, that's a good one. Do you represent UK? No, not this year. Hopefully the next one. We'll see. Okay. That's enough for that. Close that down. Okay. Am I reading the question right? You always could ask yourself this, guys. If you're finding it hard, it might not be your skill. It might just be you're reading the question wrong. So, That's an angle. Theta. And LBK equals LNC. Okay. Okie dokie. So that's theta up there. And oh my days, oh my days. Oh my god. Oh my god. Yeah, I can see why this slimed everyone out, guys. This is... Although, it's only been an hour of me doing this question. So, the game's not totally gone. I reckon if we can solve this in the next hour, we have a chance of getting all three. So yeah, that's KBC, CNL. Okay, you guys have no idea what I'm doing, so I should probably do some stuff here. Theta. And this angle is equal to this angle. Very nice, very nice. KGF, guys, Indians in the chat, angle KGF. I'm losing the plot. KGF equals FVG, right? So how do you connect? How do you link them up? I don't see the vision. I don't hear it. Okay. This angle. So this is theta. This is 180 minus C minus theta. Okay? Yeah, that's 180 minus, because this is C, so that's 180 minus C. Yeah. And that's that full angle. And this is like some T, so this is 180 minus C minus T. Bro, this is... Oh my god, this is not ideal at all. T, and then because MNFG, the cyclic, it follows that MFG... Come on, give me a good one, give me a good one. MFG is T. That's T. How do you get this? How do you get this? Oh, that's dark days. Check in chat. Did Sidorenko solve this? Yo, probably, like, he can do any geometry, yeah. I talked to Michael. No, I haven't yet. Are you studying from Otis? No. Where'd you find the problems? God sent them. And, yeah, tough. But yeah, I reckon this is something that Sidorenko would solve very, very easily. Okay. ABK. equals ACL. Like Joseph, shout out if you're watching this, you know, does that. I wonder if that hits close to home. I hope he's watching this at least. The ABK equals ACL. Okay. KBL equals LNC. Oh, mate. Oh, my days. I'm doing the wrong lines. Oh, my God. Yeah, that's... Oh, my God. That's so embarrassing. Wait, is that... Am I doing the wrong lines? Yeah, I had the diagram wrong. Oh, my God. That's actually dark. My days. Yeah. So guys, make sure, you know, if you think you're stuck, it might not be a skill issue. It might just be that, you know, you're very stupid and you do stupid things sometimes, right? So, okay. Oh my God. Yeah, so let's draw the diagram correctly. And yeah, so it wasn't the issue wasn't with any of the points. It was with the points I added. So we had ABK equals ACL. So what I need to do was actually extend CL and BK, not the other way around. Okay, let's go to a new place. Somewhere entirely new. Okay. So I got a circle with center. I'm not even naming the points, man. I need to solve this. My God. Oh my God. Yeah, always check, guys. If you have no progress, it's not because you're bad at maths. It's because you're just stupid in other senses. But okay. A, B, C. Then we mark midpoints, so we go into the construct section. And we draw those triangles in, because with a goat, that's almost isosceles, so we can fix that. And then we mark 2 points, one in triangle. Okay, I need to name these actually. B, C, and so be very careful. So A, B, so J becomes M, and O becomes N, and this becomes our new circumcenter Y. So P, well, we'll call this K to avoid any confusion. So K is in BMC. And triangle, so we form triangle AKC, and L is in triangle AOB. But yeah, I'm gonna actually go ahead and hide these 2 segments because they confused me last time and we don't want that. And the segment here, so it's like that. Yeah, so GeoGebra is very good, but this is why I would recommend practicing freehand. You know, you get a lot more like time you spend actually doing the question instead of, you know, just drawing a diagram. So that's cyclic, and so is this. And yeah, we also have, okay, hold on. That this point D is actually our point L. And then, yeah, we had LBK. LBK equals LNC. Oh, sorry. That's not right. And then F, and then G. Bro, I've never, literally in my life, I've never sat still for like this long. So, you know, guys, be thankful. I'm doing so much for this stream. Let's check chat. Bye, please give me some tips. Watch my latest video. That's pretty good for tips. Joseph working at his desk internship at Jane Street right now. I guess, man. Cool. Wait, how do I close it and still see the stream? There you go. Stream is up, ready to go. Okay. Now. Again, we had LBK equals LNC. And yeah, so that means that. So that, see, now that's so much easier. That's so much easier. Because now we just have B, F, and L cyclic. You can immediately see that because we have a proper diagram. And now, yeah, so by symmetry, or the same argument, C, G, K is also cyclic, along with B, C, F, G. That's cold. That's cold. Okay. So you got that. You got 3 cyclic chords. I reckon that's pretty useful, guys. I don't know about you, but we can't use. It seems like there's some radical axis type stuff going on. Like BF is the radical axis of Wait, hold on. Like these two circles have a radical axis BF. These two have a radical axis CG. But you know we can't use the radical axis theorem because there's 8 points here and 3 cyclic quadrilaterals. So yeah, but it does imply there's some like power of point stuff going on, is what my motivation is. But yeah, okay. Okay. Right. So, okay. Now we can look in this quadrilateral. So, essentially, no, I'm just saying words now, guys. But we want, what is it that we wanted to show again? It was, so if O is the circumcenter of AKL, then OM equals ON. Okay. AKL, nice. Have we used the fact that they're midpoints? I don't think so. So that's got to be useful. So yeah, let's take a minute. So this is our question 1 work. But let's take a minute to find a new space for question 2 and type out some ideas. Okay, that's pretty huge. Type out some ideas. Oh, come on. There we go. So we've used the angle condition, and so we need to use M and our midpoints of AB and AC, cyclic quadrilaterals, and we haven't brought in AKL or circumcenter of that. We haven't done that, so that's something we need to do. All right, sweet. So, okay. Which one does it seem like? With cyclic quadrilaterals, I think a good way to go would be, so power over points. Because we have so many radical axes. I just feel like it's got to be the way. What do you say in chat? Can I join? Yeah, you're with us right now. You're on the stream. Welcome. And that's all that's been happening. Active stream indeed. Okay. So we can just, maybe we can start. This reminds us. That's a good shout, actually. I should have thought this earlier. But I'll go into here. So a good thing, useful thing in Olympiad maths, especially geometry, is you wanna recall past problems, right? Because ultimately, when you stop thinking problems as like this impossible thing, you start to realize that there are things that people have had to come up with, right? And often, a lot of people, they come up with questions using previous questions as inspiration. So this condition, random circumcenter, midpoints equal, that reminds us of IMO 2009, problem 2. And spoiler for that problem, so put this video on mute or like just shut it down for the next 5 seconds, is the key step was we want to show that the power of points of M and N with respect to the circle are equal. So that's the key step. And we want to try and, so going back to the diagram, we want to try and link M and N to the circle. But the issue is there's no lines immediately that give us that. So maybe some observations down the line, like this is very likely our finish. This is very likely the last step of the question. And so, like I talked about, charging versus, I'll make a video on charging versus conjuring actually. Charging and conjuring. That'll be the third video in this series. But charging and conjuring is, so we're charging. So I mean, our conjure is that M and N equal pop to AKL is the finish. And we're charging with our cyclic quadrilaterals, and we're gonna use pop to try and get as much information as possible. Okay. Where's the diagram? There we go. So, okay. So you got CG, radical axis of these two, BF, radical axis of these two. So, maybe link CG to this one, I guess. C and G, we have, so this is what we use. We can use midpoints here, actually. Yeah, we're going to use midpoints here because the power of C with respect to this circle. Ooh. Guys. Okay. Fine. So C, link it to, yes, this might be the play. We might just have it. So let's see. C F times Cn is the power of C, and it's that's, so this will use midpoints, so we can get that checked off. It's half C over 2. But now CF over 2, we can introduce a midpoint of CF, like C. No, we'll call it CT. And yeah, so if we add the midpoint there, we get CT times CA is equal to CF times Cn. And midpoints of, remember, B, C, F, G is cyclic. So any midpoints, we can drop in the circumcenter, which we can probably circumcenter of AKL, anyone. We can probably link circumcenters to each other much more easily. So that's, we're probably cooking on something. Call it S. And we have that ATS is a right angle. So again, if we add another midpoint T2, then again, we can get this. So, yeah, that's very good. That's amazing, in fact. That's astounding. But that's, I don't, okay. And yeah, so that gives us a circle AT T2, and C C is on the right axis. Between that and B, F, and L. Yep, that's right. Which means that if L, hang on. But no. But wait, G up here, the power of it with respect to, let me zoom in, what the fuck? BFNL, the power is, what's the power, bro? What's the power? Can you even get the power, man? Like, it's kind of tricky. It's kind of tricky in my opinion. Is there a code that it goes through or something? Like, how do we get that? Cause like, you got that nice line there, but, oh man. Cause what I was thinking was, if you can show that G also has equal powers to both circles, then CG is the radical axis, L is on that circle, and so is K. So as it turns out, we get the circumcenter is like the midpoint of this line, and then by homotity we'd be done. So all we need to show, guys, is so CG radical axis. That's all we need to show. That's it, and then we're moving on to question 3. Okay, that seems, because you already showed C has equal power, so maybe the hard part here is showing that G has equal power as well. Okay, let me do this. It's the chat. I'm from India, I want to get a good Olympiad. PowerPoint conjecture, that's right. But, okay. CG radical axis, that's all we need. And yes, that was, see, like, guys, don't worry about, if you're 2 hours in, you haven't solved the question, like, don't worry about it at all. Because my coach, the UK IMO team leader, he told us that Olympiads, when you solve questions, they aren't 4.5 hours of work. Often it's 3 10-minute bursts of flow state. So yeah, time is not an object, and the time you spend thinking about the question will help you, form ideas in your subconscious that help you, get that aha moment. Which, I'm glad that happened on live stream. That's nice. JEE. Son, oh my days. JEE. Unless all you think about is a man who thinks has nothing to think about but thoughts. Let that stay with you. But yeah, also make sure that you're locked in. Like, I remember in Balkan, I just couldn't tap into, the Mass Olympiad. I couldn't tap into flow state. I don't know whether it was like the room. Same thing happened in BMO too. Like, it just never felt I was present. So really, like, just try and prepare yourself for the environment of the contest. Is another thing I'd say, because when you want your brain to have as little distractions as possible. So like when you know the place you're going into, you know where you're sitting, you know how it's gonna feel like. Your brain isn't processing that new information. It's just it's part of the background. Okay. One last thing we need to do is show that G is on the radical axis, so that CG is the radical axis and L is the thing. Ooh. Okay. Anyway, we can project out or something. Project. Can we get like a point here or whatever? I don't even know, man. Okay, so let's think about power of a point with respect to the other circle. It's GA over wait, no, sorry, we were talking about wait, what? Dude, so the power of that would be GA over GA times GT2, which is GA over GB over 2, and then GA over 2 becomes so we can add in like midpoint of GA and show this on the circle. So like right here. And if we show that that's on the circle, then we should be done, I think. So yeah, it looks like it's on the circle. But then again, we don't have an accurate diagram. Let's zoom in. Okay. Bro. Did I do IMOs before? No, I haven't. Well, if you're talking about international contests, I've done 2, RMM and Balkan, but I've never done the IMO before. Gang. Because no, so we know that the problem is like, it's surely equivalent to CG being the radical axis, because then BF would also be a radical axis. But I don't even know if you guys can hear me. I'm just trying to see if that works. Oh my days. Pro tip for mass contests. Pro tip for mass contests is go to the toilet. Go to the toilet a lot. Bro, my phone is giving me reminders that I need to take a break. Oh, I think so. I'm chronically online, which I guess I am if I'm streaming. How was your experience in the Balkan competition? I have heard it is hard. No, weird thing actually, like, the Balkan, I don't think the Balkan is that hard, but I had a really bad time in it. Yeah, I was talking about it earlier, like, I just couldn't lock in, I couldn't do the questions, you know. I don't know what happened, honestly. It's pretty much 12:30. I've been streaming almost 2 hours now, which is, yeah, dedication. Dedication. Okay. Literally, we just need one final thing, guys. The G on the radical axis. That's all we need. One final thing, and we're done. We're done. Let's close up the stream. Okay. So we had. Oh, I called 2 points S. Let's call this $sign, right? So we want to show. So if $sign is on BLNF, then we're done. And $sign is on BLNF because AG times AB equals AF times AC. So, wait. Yeah, AG times AB equals AF times AC. So yeah, yeah, so divide by 2 and you get a dollar sign AB equals AF times AN, and that's how you use the midpoints again. Yeah, a dollar sign times AB. So that's on the circle. Then we can pop from G, CG radical axis, L is on it, K is on it. So if we take homotity from A, like so we know that this is the circumcenter S. So BS equals CS, and then homotity from A, scale factor a half, MO equals ON. Very nice. Very, very nice. That's gotta be, I don't wanna glaze it, but that's gotta be like the best IMO P2 of all time. At least one of them. It's probably the best of all time. Hip hop you selected IMO 27. Yeah, me too, man. But yeah. Okay. Now, before we do question 3, I'm gonna go over exactly what I did in my last video, which is reflecting. Because I think with question 1, there was nothing to reflect on, at least for me. But we're gonna do P3. Don't worry. Reflecting is, I think the main trick was, so with power of a point, midpoints can sort of be like moved around. Be moved around. That was the main trick, which I don't think I've seen before. I think it's very, very nice. And it's probably going to come up a lot more now that it became popular with this problem. See, because we had these midpoints, like, so for example, in this finishing step, AG times AB, we had this cyclic quadrilateral earlier, and we could actually, no, this is not the best example. Probably a better example would be to look at, I did some stuff here, or was it C, something like that. Where is it? Yeah. So the stuff on proving C is on the radical axis. We had CF times CN becomes CF times CA over 2, and you move the half to CF, which allows us to introduce a midpoint. And midpoints of cyclic quadrilateral sides, cyclic quad sides are good points. They're very good points, because then you get right angles, right? So yeah, that's, anything else we can take away from this question? I think reinforces a heuristic. Like how I always approach geometry is, you want to translate. So think of it like a little bit like linguistics, right? You're given a statement in some goofy ass language, like I don't know, man. West Gabonian or something like that, right? And you want to get it eventually to English, but the languages are far away. So if you do it directly to English, you'll lose meaning or whatever. So you wanna translate it into something else that's easier to move straight to English from. Like in this question, we had a very annoying angle condition, which actually, when we just thought about it, became a very nice cyclic quadrilateral condition. And from there, I could easily use pop to finish the problem. So that's a good heuristic to reinforce. It's characterizing bad conditions. Like, I think, again, my friend Michael, Arts of Olympiad Mathematics, he has a very good video on good point, bad point. And I think from this, we know that K and L are bad points, very bad points. But the cyclic quadrilateral stuff, they're good points. So we work with them, the good points, to try and tackle the bad points in the question. And yeah, that's question 2 done. I'm gonna... Let's see. Yeah, let's just check chat. Read the question so that you don't... Yeah, again, if you add points, be very careful you're adding the right points in your diagram. Because it's very easy to draw the wrong lines, especially in a complex diagram like this question, and you can lose half an hour of real contest time, which is around 12%. So that's not good. AOPS books. I don't know. I never actually used AOPS books, to be honest. I didn't use that many books. I'll talk about what I did again in a later video. But yeah. I'm gonna go and get my power snack and I'll be back in like 2 minutes. Oh, might be the world's first maths YouTuber to give out looks maxing advice, but some milk and honey, best thing for you, especially get some whole fat milk so it doesn't mess up your skin, and yeah, makes you healthy, makes you happy, makes you smarter as well. So yeah, that's one thing I don't think many people actually talk about this, but you need to if you want an advantage in maths, especially because like there are some people that are just very talented, they're very smart, they're born with the ability, but people like us, we had to work for it, right? Of course, we're a little bit above. If you're into it, you're probably already like the smartest or second smartest guy in your class. And one thing no one talks about is being healthy, because ultimately, like maths Olympiads, you're using your brain, right? And your brain, how well it works, is determined by how healthy you are. So yeah, stay healthy, guys, and we'll do We'll do question 3 now. Alright. Liao Bang. I actually do Mandarin, so I should be pronouncing that correctly. "12:30 at night, gang. It's 12:30 and it's 12:30 in the afternoon." But yeah, okay. So in UK it is night. No, it's not, guys. It's afternoon. Search it up. It's afternoon. Come on. Okay, Liao Bang and Xiang Yu have a stick of length 1 and want to divide it between themselves. Let's draw the stick. I love so much space. Let's draw the stick. Here we go. Okay. And want to divide it between themselves. Marks the most endpoints on the stick, and then Xiang makes and most marks after Liao marks the endpoints. He marks endpoints on the stick as well. Distinct points. Then the stick is cut at all marked points, creating a number of pieces. Afterwards, they take turns claiming any unclaimed piece of the stick, with Liao going first. Each player's goal is to maximize the total length of their own pieces. So, okay, we end up, essentially the problem is like you cut it in some places, you end up with some pieces of some certain lengths in increasing order. And yeah. So let's say that's the 2k plus 1. 2n plus 1 actually. Because if there's 2n cuts, then there's 2n plus 1 pieces. So again, there can be less, you know, could be less. Actually, no, we'll say that there's 2n plus 1 pieces, because we could have pieces of length 0, right? So, what is it? Liao Bang has a total of x1 plus x3, because what it is, they end up taking greedy, right? If they don't take greedy, wait, let me just double check that. If they don't take greedy, that's objectively bad. So, yeah. Greedy means they just pick the largest stick, so it says distinct, so it's always 10 plus 1. Yeah, I know, but they mark at most endpoints on the stick. So they could mark 1 point each. That would be less. What's your Discord? Can't be giving that one out, mate. Sorry. So Liao has this much, and Xiang has the rest, the pieces that are ranked in the even position. Okay, cool. So we want, this is, see, like, in principle, this is such like a simple thing to think about, but that's why it's probably like hard as fuck. Man. China don't play around. Like, P2 was already pretty hard, I think. I mean, it wasn't that, if I can solve it, it wasn't that hard, but still pretty hard. How to initially start praying for high-level maths. Yeah, so you want to start from easier questions than the IMO. Right. Are you in school or you study maths? What will you do after graduating high school? I'll probably study maths at uni and then I'll see where life takes me after that. Okay, back to the question. So ideally, it seems like Xiang can probably, because Liu already has this advantage piece, right? X 2n plus 2n minus 2n plus 1 is the advantage that Liu has over Xiang, which is why he will always end up with more. So Xiang wants 1 to minimize x2n plus 1, and 2, he wants to make the other values as close to each other as possible. So ideally he would like for this identity to be true. That's what Xiang wants. We should probably do some small cases to find out more about the question now. So okay, someone asked in chat, what if n equals 1? Well, yeah, so Liu gets x1 plus x3, Xiang gets x2. So if Liu cuts, say he cuts in the middle, Xiang doesn't have to cut. Remember that. Yeah, Xiang doesn't have to cut at all. So from this, we already won. So yeah, if we get 2 pieces, A and B, then if Xiang, wait, hold on, let me zoom out. So 2 pieces A and B, for Xiang not to cut, he's happy with A. Wait, what am I saying? So if A is less than B, right, then Xiang can cut a piece length A left over with T, right? So the guy's got A plus T, Liu, and Xiang has A. Think so? Yeah. This is pretty tricky. And then we want A plus T over 1 to be like... Okay, so what if these 3 pieces are all equal? So if like guy cuts here 1/3, 1/3, 2/3, the best thing Xiang can do is cut in the half here. Or like, no matter what, Xiang will always get 1/3, and the guy will get 2/3. So, yeah, what do we... From small cases, when you do small cases, you always want to analyze what did you learn? And what did we learn? We learned that 2 pieces... Okay, that's pretty damn small. Gang. Hello? 2 pieces close in size to each other equals bad. And we also learned that there is a 1 to 2 kind of ratio type thing. First person doesn't have to cut, but if the first person doesn't cut, like, okay, so we can prove some forcing things about this problem actually. It might simplify things to first prove I'm going to type because writing with a mouse is painful. Prove that Leo has to make n cuts. So if he doesn't have to make n cuts, like let's say he makes less, then there are less than or equal to n pieces. So what can our guy Xiang do? He can just cut every piece in half. There are n pieces, less than or equal to n pieces. So he makes n cuts them all in half, and then they share the stick equally. So Leo has to make n cuts. Fine. Now we can look at n equals 2. Okay, so n equals 2. Following like 1, 2 might help to look at 1, 2, 4 type pattern. So 1, 2, and 4. Obviously all over 7. Can we see that regardless of the cutting, the first person is guaranteed more than or equal to half, because ultimately, like in both sums, like the first terms, so we call this majorization. So the first person's values majorize the second. Like each term, it's is bigger. Yeah, exactly. We can do that showing x1 is more than x2, x3 is more than x4, more than or equal to. So yeah, we know that C is at least a half. Yeah, let's see what this yields us. So if our guy Leo cuts it like this, then what can Xiang do? Okay, maybe we can try finding a strategy for Xiang. What SI number do you think P2 is? I don't know what you mean. So if n is 1, then let's say we got A and B, right? If B is... So we think the answer for n equals 1 is 2/3. You want to Leo to force less than 2/3. So if A is more than or equal to third, A less than B, by the way, then A makes 2 cuts, so Xiang will get at least A. However, if not the case, then B is more than or equals 2/3, so Xiang can cut B in half to win. Oh, SL. I think P1 will probably be N2, and P2 will probably be like G3, G4. Probably G3, because I can't do G4s. Yeah. And yeah, we're doing P3 right now. Oh, mates. Okay, so for n equals 1, we've confirmed the answer is 2/3. For n equals 2, let's say, also a nice thing we can do is rearrange the cuts, right? Rearrange them. Okay, yeah. So essentially a reductive, it doesn't actually do anything, but it makes it easier for us to write up, I guess, if we end up solving it, is x1, x2, x3. And we can, sorry, no, let's call it c1, c2, c3 to not get confused. Let's see. Yeah, so again, I think the key to this will be in the powers of 2. Powers of 2 is in, because our argument relied on if b was more than 2a or b less than 2a. That's what our argument for n equals 1 relied on, so we can probably try something similar here. The strategy. So if c3 is more than 2 c1, then we can cut, similar to n equals 1 case, we can cut c3 in half. If if c2, or more than or equal to actually, if c2 is more than wait wait. Okay. That is massive. That's huge. Okay. So I should draw the stick again as well. Let's say we have a sequence of cuts, as shown. I'm gonna try and generalize the strategy for Xiang that we did in the n equals 1 case, but for all n. So essentially the strategy was, let's say if Cn is more than or equal to 2Cn minus 1, then okay, we should define some things, right? So definition 1, we're going to consider our stick in play, or like cut that's in play is just the one we are considering for this process. And definition 2, no, I don't need a definition 2. Oh man, maths is hard. Definition 1 is the cut that's in play. Like, it's just the one we're considering for this process. Definition 2, well, yeah, we can also consider the cut that's opposing, I guess, the other cut we are considering. Start with selecting Cn as in play, and oh wait, no, I've got a better way to put it. I'm keeping you guys on edge here because you don't know what I'm thinking. But yeah, so start with, at any point, rearrange the cuts in size order. At the start of Xiang's process, all of the cuts are, let's say they're black, right? Xiang then selects Cn and Cn minus 1 and does the following. Can we get a formula up here? We can, but I can't be asked. So if Cn, the largest cut, is more than or equal to 2 times the second largest cut, then we can... What can we do? We can cut Cn in half and color both halves. Well, color both halves. What is damn black and move on. To the rest of the n-1 cuts and repeats. Else, if Cn is less than 2, Cn-1, then cut something Cn-1 in Cn, color Cn-1 and Cn black, reshuffle the rest and move downwards in this way. Okay, so now we want to find out what, so essentially we end up with a final stick that, so this strategy, why we're doing this is because we talked about earlier, Xiang wants things to be equal, because if things aren't equal, then Liu already has the advantage of the final piece. So, my days. You know, we just wake up with a bad neck. Man, that's rough. Xiang wants to make sure that there's no other advantage. Okay, that's convenient. So, I'm sorry. Color, they're already black, so color them like white. Okay. Advantage of the final piece. Xiang wants to make sure there's no other advantage. Okay. And this strategy, we create pairs of equal pieces. So this strategy gives pairs of equal sizes until the last piece. Yep, Xiang wants to minimize that difference. Yeah, that's right. So that's why he wants things to be equal. The strategy gives pairs of equal sizes until the last piece. So now we want to find out what the size of the last piece is under this strategy. Maybe, can you demonstrate that strategy with an example? Okay, sure. Yeah, I'll do it. Actually, yeah, that's something I need to do because we need to find out what the size of the last piece is. So let's say we got cut sizes 1, 2, 3, 4. What the strategy does is, so look, you select the two largest, and 4 is less than 6. 2 times 3. So we can make a cut 3 and 1. And this 1, we can rub it out, move it here. These two stuff, we're done with them. And now we're looking at 2 and 1. Again, this is, so now this one, it's larger than, so 2 is, wait, what? 2 is large. I'm just writing shit now. 2 is greater than or equal to 2. So we can cut 2 right here. It gives us 1 and 1. And we're done with that. Now, again, we had 3 cuts, I think. So 1 cut is 1 and 1. And we don't want to cut here. So then what we end up with is 3, because 1 and 1 are already equal. So, oh yeah, if 2 things are equal, that's another thing we need to add. If 2 things are, if the 2 sticks being considered are equal, then do not cut, color them white, and move on to the rest. So essentially just making as much stuff as equal as possible. I don't know. When my mic's attached to my vest, can you guys hear me? Like, I don't know. I always think like, oh, I'm probably really quiet. But I'm gonna attach it back regardless. Come on. If possible, make sub. Yeah, they're in the works, bro. Don't worry about it. Okay. Now, I think this we're actually kind of close. This surely isn't gonna be it. I am from India. Love from India. Love back to India, my friend. Okay. So now we just need to find out, essentially, what the size of the last piece is. Do I know how UK did in day 1? Whoa. No, I don't actually. I had to set up a stream, so, you know. Please don't forget to make video on that, of course. Actually, no, I do know. I know of 2 people. One of our guys, well, Alex, the best in the world, he got everything. And I know of someone else on the team who maybe got everything, but I'm not too sure. How is this strategy? So start from the longest block and cut each in half until the last one. Maybe that works. If this doesn't work, then I'll try out your one for sure. So yeah, the strategy we had, it worked. Actually, no, let's try out the suggested strategy on this one. Then we get 2, 2, 1.5, 1.5, and then 1, 1, which still leaves a size of 1. Yeah. So if you do that, you always end up with the last piece. But if you do this strategy, sometimes you end up with 0. Okay. Now, what is the size of I'm bugging out. Bugging out. What is the size of what's left over? Okay. Let's do it. Oh wait. Yo. No. So yeah, so consider the two sticks we're making a move on. So A and B, right? And A is less than B. So no matter what, so let's say B is more than 2A, then the next stick we're considering is A, because we then cut a B in half. So then we B over 2 is less than A. So the next stick we're considering is always less than half of the previous one. And if B is less than 2A, then B minus A is the next stick we're considering. Or is it? Hold on. Gang. Okay, I don't. Seems to be a little more complicated than that. Because thing is, we make A and B minus A. But if B minus A is really small, then it just goes to the back. And we consider, so like A, B, A, B minus A. But then B minus A just goes to the back. So okay, let's try another example. Because this strategy, it matches all of our heuristics that we approached Xiang's strategy with. So if you go 1.1, 1.2, why did I take those two cases, by the way? Well, it was our strategy for n equals 1. So when we had two sticks, we had to do different things for when B was more than 2A and B was less than or equal to 2A. B is more than or equal to and B is less than. We had to do two different things for n equals 1, so I figured the general strategy might have two different things as well. One 1.4, 1.5. Right. So then there's 4 cuts. So in our ideal world, the remaining stick we have left over just is governed by this. So each time the stick we're working on halves and moves, so ends up being like so yeah, if you have if we halve on 3 sticks, then it's 4, 2, 1. So the leftover will be 1 over 7. And in general, the leftover would be 1 over 2n plus 1 minus 1. Yeah. 1 over 2n plus 1 minus 1. So that's what we want the leftover to be. There are 4 cuts here. So 4 cuts means in an ideal world, 1 over 2 to the 5 minus 1, 1 over 31. And yeah, the answer would then be, I think, so if Liao minus Xiang is 1 over 2, 10 plus 1 plus 1, then Liao or C would be 2 Tn over 2 over that. Say no more, guys. Say no more. That's very close to a half. So it's probably not too hard to prove he can achieve this, because it's not that good. He's not achieving much if he does that. Okay, anyways, back to the strategy. So 1.4, 1.4, then 0.1. So we cancel those two. Went to 0.1 again. So we can cancel those two. And then 0. So we made 2 cuts. Now we made 3 cuts. 0.5, 0.5. Cancel those 2. And then this one, no cuts. So we just win. We just win. Like that. So that this again gives us 0. This strategy is pretty damn good, but we just need to prove that it works. Alright. Come on, we're actually really close. And if we can get this right now, that would be sub 3 hour IMO 2026, which would be fucking crazy. Whew. Right. Okay. So again, strategy. This is our strategy. Right. Man. But the maths is so tiring, I swear to God. Okay, so we have an answer, which is given by the ideal case. And let's try and prove that our guy, Leo, has a way to achieve it. So, Leo. This is Leo's strategy now. And it's ideal when we had the geometric progression split. So we're going to do exactly that. This is it for n equals 2. And 1, 2, and 4 is what we have. As in the side lengths. Well, 1 7, 2 7s, and 4 7s. And we have to prove that no matter what Xiang does, Leo always has a difference of 1 over 7. Okay. So 2 cuts literally anywhere, right? 2 cuts. And we want x1, x2, x3 plus x5 minus x2 minus x4 to more than 1/7. Okay. So if we cut any points here and here, then we get, so A, B, C, D. And, so well, one of these guys is the largest. So let's say C is the largest, so A takes C. And then a guy takes D. Then we take B, then A. Okay. Let's go 2.5, 1.5, 1.4, 0.6, and 1. So 2.5, then 1.5, 1.4, then 1, and then 0.6. So again, these differences here are like pretty huge. This already covers exactly what we want. Just this alone, just that. That's exactly what we want. Man. How do you do the strategy? I just don't hear it. It seems like we have a way for Xiang to win. To win, no, not win, but to get the answer we want. And this Liu has to do this construction. Like, there's just no other way that works. Because if Xiang does a strategy that we did earlier, he gets 1/7, which is what we want. Or we could, I think it's just induction actually. Yeah, so yeah, I think it's got to be just induction. First, we prove that Xiang has to make n cuts. First, we prove that. And then we can induct, because let's say like, so if there's or we can induct on the claim that if Xiang makes n or less cuts, then he wins in that series. Yeah, that's actually pretty easy. Because, so if you have 1, 2, that's the base case we have. So we're inducting on essentially how many power of 2 strips there are. So you got 2 to the 0, then 2 to the 1, then 2 to the 2, then 2 to the 3, right? We're inducting on how many strips there are. And we want to show that if there are I plus 1 strips, then if Xiang makes k, which is less than or equal to I, cuts, the we always get a good difference. Okay, fine. I think it is just induction, at least. Could be wrong. Wouldn't be the first time. Yeah. It's gotta be. So, again, let's say there's no cuts in the strip we have here. Then, Leo takes the largest strip, so the new strip, and I guess he just wins, right? I guess he just wins, no? Yeah, then Leo takes the largest strip and wins. Because the second largest is at most this. So this difference is enough to make up for the gap. Which means that there must be a cut here. So there are n-1 cuts here. Mates. IMO 2026 P3, let's go. And there are n-1 cuts among the first n strips. So if we have by at most n-1, we have by induction that, like, you know, this sum in the n-1 is more than 1. So when we add some stuff in, add some shit in. This is why you stick to bio. Fair enough, mate. Fair enough. Oh, holy difficult. Holy difficult. Okay, I reckon we can come back to that. But if we have a strategy here, we're so close in both parts. We have both strategies, but we just need to prove that they work. That's it. But I don't know, especially for the part we were just doing, I feel getting the strategy is honestly quite easy. So it must be the proof's difficult. It must be. I don't know. My days. Such a stiff neck. Let's see, chat. What did you mean by cut something? Okay, so time for a break again. God damn it. What do you mean by cut something? Why did I write that? Okay, so I mean like cut something of length. Cut a piece length cn minus c of n minus 1, and it just works, I guess. But how? So we want to prove that the final piece in the strategy is it's pretty low. That's what we want to prove. Okay. So back to this section. So does this make it does, yeah. And I want to show it makes the final piece smaller by a factor of 2 to the n. Or 0. Or it makes it 0. One 1.5, 1.4 again. But this time we go like 1.3, then 0.7, and then... Okay, let's just try with this, right? Damn, okay, so we've been coming up to 3 hours right now. Still more than 1.5 hours left, which is good, which is very good. So yeah, our strategy, we cut, that's out, 0.1. Now 0.7 is more than a half of 1.3, so we cut, and that's out, which gives us a leeway of 0.1 again. Does it? No. 0.1 now goes here, and then we get 0.6. And then, so there are 3 cuts, so we can cut again to get 0.3 and 0.3. Okay. So 2 possibilities here are, the first one is we cut, do a half cut, and in this case the cut size always halves, at least halves could be less than half too. The other one is we get a cut less than half of our working one. Is it necessarily less than half? Yeah, it is. But it doesn't have to be the next cut we do a move on. But yeah, even then, wait. So in this case, we just go down to the next lowest. cut. Oh man, why does that also help us? My days. What if you tried something like 1.4, 2.5, 1.3, 1.1, 0.7. So that, no, sorry, just that. So that cancels. It goes to 1.1, which slots in here. And then all this goes to 0.2, slots in here. 0.7 just halves, so we're left with 0.2, and that is 1/16th, 1/15th, maybe? Yeah, it is, because that's far less, far less. So yeah, this problem's getting quite annoying now, because we just gotta, we know that we've done all the combinatorics, we just have to do the algebra. Ooh. Is this an algebra problem or a combi? I don't know, man. Bro, this is the most I've ever sat down in a day. Oh my days. Sweet. Do a half cut. Yeah, so why does the other way also always halve it? I don't hear it. I don't hear it. So way one always halves it. But way two, if you have like 1.4, 1.3, well, let's say 1.4, 1.1, that goes to 0.3. But that's less than 0.8, so it doesn't halve. Well, then 0.8 goes to okay. Suppose, okay, let's do this. Total n cuts. I guess, yeah. if there are d total n moves actually. So let's say there are A moves where we just half it, B moves where we do the other operation, and when I say minus B moves where it's just the equal halves type shit. I just don't see why. And I've said that for. Please turn dark mode on. Hell no, man. Yo, dude, your IMO video was lit. Really loved it. Thank you, bro. I'm glad I could add some value. But damn, this IMO question 3 is testing things. Very different experience to question 3 last year, for sure. Yeah. Yeah, wow, the IMO question 3 is hard. Who would have thought? Who would have thought? That's crazy, man. Oh my days. I'm genuinely about to fall asleep. I'll be so honest. But no, I said I'm gonna do my best to solve all 3. I said I would solve all 3, so that's what I plan to do. And yeah, so right now we're trying to prove that no matter what, the final cut piece, we could try a global thing. So even though it doesn't half every time, at the end it's a piece of 1 over 2tm plus 1 minus 1. And maybe we can like work backwards and assume that it's more. And so if it's more, then that's got to be it. That's got to be it. We can consider the reverse process of... so this piece is still black, I think. Yeah, this piece is still black. So we can consider the reverse process where we just... yeah, we can combine stuff together. And how do you do that? Oh my god, oh my god. So we go, this piece is left, and then this piece is a pair, so where did this piece come from is what we want to find out. And well, if that's a pair, let's look at the final move, right? So the final move leaves this and creates this pair. So if that's a pair, then it has to be that this is twice the length, I think. Yeah, because you got C, C, and something that's less than C. So that's twice the length, right? And then we can undo that to get TS. Now, so this came from somewhere, and this is the, well, we either have something of length C and something like C plus D. So remember, this is D, and D is less than C. So C and C plus D. Or we could have just had D into C. But yeah. So this is 2 times that, and this is just more than that. So now I'm going to look at where this one came from, if it came from anywhere. I think it's like something, you know, you got this piece and then the move it came from has to be times 2 at least, and then it's times 2, and then it's times 2. So overall, when you sum it, you know, you get some good shit. So yeah, then now it's 2C plus D, which is 3D. And then C has to have come from, if C came from anywhere, which doesn't have to be true, but let's say it did, then it came from like F, F, and C. So you can replace that, I guess. F, F plus C. But now, because we did it increasing order type shit. So that's 2D, D, 2D, and 3D. So now this is 8. What the fuck? No, that can't be true. That can't be true. So yeah, C came from F and F plus C. This is at least 2D, so that's at least 2D. Or if we just look at C and C plus D, then we can see that, so this is like 2D. So wherever it came from, like these two pieces, X, so it came from like 4D. Yeah, I think that's good. So basically, we go reverse, look at where, yeah, this works. I think this works. So work in reverse, look at where the piece came from. So if we end with a piece black piece length L, then there has to have been a Then in the previous move, the total piece length was, that came from like C and C plus D, both more than, C and C plus D, yeah, that works. Or it could have just been halved, so total piece length was 3L, and yeah, so no matter what, any piece that's currently black is has less length than any piece that's currently white. So we think about the next two. Either is like a half type thing. Say wait, the next two are paired. Gang. What? Oh my days. Okay. Yeah, so I think this is it. Watching this as a JE aspirant hits. Oh, poor you guys praying for JE. So yeah, D, if we end up with D, or L actually, then we get to 3L, and the previous move, it's 7L, and then so if we have a spare cut, if we ever have, so we never get the baller, we never get a pairing, because if we ever have a situation where the two things we do a move on don't have equal size, then we have a cut left over. And we can use that on the last piece to cut that in half and get, hold on, wait. Okay, so what am I saying? Let's say we have something like two, then 1.5, then 1, okay? So then that's a cut we don't need to use. We have wait, does that just work? Because then we have two cuts on two pieces. Yeah, that just works. So that never happens, which means that we never get a pair that's formed out of thin air, right? So everything comes from somewhere. And yeah. So this only fails if the piece doesn't come from anywhere. If it does come from somewhere, then it happens later, and then you get this nice argument. So essentially, if we start with L, then reverse one move, 3L, reverse two moves, 7L. So reverse n moves, essentially it's 2 to the n plus 1 minus 1 L, which implies that L is more than or equal to 1 to the n plus 1. sorry, less than or equal to. So this strategy works. Like this strategy is the GOAT strategy, right? We solved half of the question, I think, which is like a huge, huge W. Now we just got the other half left. Oh my days. Oh my days. Oh my days. Honestly, like, am I gonna get flamed for saying the geo was harder? I mean, I don't know. This could be the hardest part, honestly. I hear you. You dreamt of representing India at the IMO. Everyone told you to focus on school studies. Yeah, man, it's a good lesson for the future because in life you'll have lots of people trying to put you in a box. But ultimately, no one has ever become successful by following a formula. You can't, if you want to truly make it, be standing out, you can't, like, the definition of outstanding is being an outlier. You can't ever be exceptional if you're doing what everyone else does. So yeah, that's a good lesson to take into your adult life, I guess. And I'm sorry that, things didn't work out the way you wanted them to in your school life. Inspired me a lot by IMO video. Thank you, thank you. In JE, I mean, I guess because IIT is very important in India, so I don't really know. I mean, I'm from UK. I live in UK. I can't comment on how important it is. So I don't know. I don't know how I can help you there. Sum of infinite natural numbers. Yeah, that's. I don't know what you're asking, mate. Sorry. But okay. All we have to do is do the what do you call it? Do the bound, and then. No, sorry. We did the bound. We're gonna do the construction, and then that's all 3 problems from IMO 2026 day 1 solved. So let's do it. Alright. This is so tiring. It's genuinely so tiring. Shout out to the people who did the IMO. Y'all got crazy commitment. Okay. We had a construction, a very nice one, that we just want to show works. And it's 1, 2, 4. Do I think Mikhailo Sidorenko, Michael, will win a silver medal? I feel like P6 is going to be Geo tomorrow, so I think he'll probably get gold, to be honest, if things go well. I don't know how he did. I don't know how he did today though. But if he would have got question 2 for sure, probably got question 1, and question 6 Geo tomorrow, so he should be good. There's another geometry question. No, if there's question 6 geometry, he will get gold. That's for sure, yeah. Okay, right, I'm falling asleep. One, 2, 4. That's what we need to do. Construct this. well, we constructed already. We just have to show that no matter where we place the other cuts, it's gonna work. So one, if we can, does induction work? I mean, well, 1, 2, no matter what we cut, 2, so there's gonna be xy. One of them will be more than 1, the other one will be, so then we got 1, x, like x, 1, y is the order, so guy always ends up with 1. And in the exact same way, well, no, I don't know what I'm saying. Oh my god. Okay. I guess we want to show that, so 3, so for here we want to show that Leo can get no more than 3/7. That's what we want to show. And how do we do that? Well, okay, so the order of the cuts doesn't matter. So we can suppose that he makes all the cuts in 4, then all the cuts in 2, then all the cuts in 1, etc. And, mates. I swear to God, we're so close, like, so close. One, 2, 4. Come on. Okay. Okay, so we've been trying to prove that this construction works with the greedy sum. But if we show that we could also do something like player 2 being greedy and player 1 following a strategy after the cuts. So obviously we assume player 2 is being greedy, but if we show that there's a strategy for player 1 to get that many, then that's enough. Like, we can think even simpler. Or not simpler, go even more general, which will make it simpler. And maybe we could try have player 1 take as many of this as possible. So let's say there's maybe like player 1 could try and have everything here, then in the next available one, then in the next available one. So if there's 2 cuts, okay, then player 1 picks the biggest. So that's like 4/3. Yeah, let's say equally distributed as well. whatever. Player 2 then will pick could pick 2. Player 1 could pick the next biggest here. That doesn't always work though. I feel like it might have to be a greedy approach. That's gonna have to be it. Or even some smoothing, honestly. So what? Damn. This is probably what makes it hard. Like the other bit, that wasn't that hard. Yeah, this is testing you, boy. This is testing. And I'm tired as fuck. I got S equals, yeah, that's... Bro's just on to something in chat. I don't know what he's on about. This is the struggle. This is what doing maths looks like. Except there's no talking as well. You're just sitting there staring at your work until the ideas come. Maybe it's not. No, but it has to be 1, 2, 4. Just has to be. Oh my god. The final stretch. This is it. This is the end. Once we get this, we're out. How to clear IOQM stage 1 India. I'm in 11th grade and preparing for JE exam. That's practice and reflect. Watch my latest video if you're confused as to what that means. Yo, Aurelia, what's good? Thanks for tuning in. This. Please, guys. I'm not trying anything though. See, this is where you gotta stop. Are all UKMOs content creators? Yeah, pretty much. Your vids are absolutely epic. Thank you, and yes, I will keep it going. Okay, so what am I trying? And so, I know this construction works. Yeah, guys, sometimes you have to ask yourself, you know, like, what are you doing? Right, you gotta take a step back. Just think about it. What am I trying? I know this construction works, so I'm trying to prove it. So, trying to prove it. How? How do we prove that the construction, which we described, always works? For n equals, so how do you prove it exactly for n equals 1? I'm telling you, it's got to be some induction, man. It's just got to be. It's got to be. Because you have some cuts here, and then you add in the cuts you made here. And there's got to be some way to arrange them to get your answer or something. Okay, so let's say you make a cut, 2.2, 1.8. But then we just win because we, oh no, we have to cut here. Oh, my days. This is the end of things, man. This is it. Gang. Oh. Man, maths is tough. Who would have thought? Anything in chat? What are your thoughts on JE? Worst exam of all time. Worst exam. Yeah, nothing. No ingenuity. And there's so much pressure put on it when I don't even think. Like, respectfully, I don't think it's that bad. Okay. Alright, I'm back. Hold on. I'll turn the mic off. Alright. Ooh. Is that kind of loud or is that good? See what you're saying. What are your plans for the future? What do you want to study and where? If you're giving it thoughts, study maths, and I don't want to say anything, but I'll see where when results come out. I'm normal volume. Okay, fine. Are you tough, bro? Nah, I wouldn't say so, man. Alright. We're back though. And yeah, what am I trying? I know this construction works. The 1, 2, 4, 8 construction. But we're just trying to improve it. And wondering how we can improve it. So let's say our guide is... Let's say we have 2. And our guide is 1 cup. If we have 2 and a guide is 1 cup, then 1, 2. 1, 2, 4. If we cut once, then if we cut once, it's very obvious. Because if we cut anywhere that isn't the 4, then we take the 4. So X takes the 4 and wins. If we cut somewhere that is the 4, so like here, then we go A, B, C, bang, bang, bang. And we win. Just like that. Okay. I don't know, man. The second we add another cut into the mix, it becomes a problem. Okay, so let's say we start just playing with this 1 cut. So we get 2.5, 2, 1.5, 1. Then we get, in the end result, we get 2.5, 1.5, 2, 1. Okay. Say no more. So this is always going to be 2. No matter where you put it, the next one will be 2. 2.5. One, 2, 4, 8. None of. Oh my god, I was falling asleep. Jeez. Maths is draining, guys. Maths is very draining. 1, 2, 4, 8. And yeah, after the first, if we do 1 cut, then the next thing is always gonna be. So it's always gonna be less than or equal to 2. First one. This one is always gonna be less than or equal to 4. And then so yeah. That's if we consider like so I'm gonna consider tuples, I guess. We got x1, x2, x to n plus 1. And at the start, we have x1 is 2 to the n, x2, 2 to the n minus 1, x3 to the n minus 2 all the way up to 1. And then these are the first n, and then the rest of them, will be 0, 0, 0, 0, 0, 0. Everything else is going to be 0. And genuinely falling asleep, guys. Come on. Come on, you still got... We're doing this for almost 4 hours. So yeah, just over half an hour left. Okay, and then in each time, we update this tuple. We update it. And updating it, I'm losing my train. When we update the tuple is when we make a cut. We make a cut in the stick, so you make a cut, and then we rearrange the sizes. So like how we did for the strategy, right? We rearrange the sizes, and then here we make the cut and rearrange the we reorder the tuple increasing order. And I'm gonna look at the sum, like this is the sum of, what do you call it? Guys, what do you call it? The thing we care about each time. Yeah, I'm gonna look at that and how it changes. Essentially, we always want this to be more than 1 over 2 plus 1 over that. We always want that much to be true. So if we show that's something that doesn't ever change, then we would be done. Wait, no, but... Nah, sorry, It's actually so hard to, like, talk and do IMO questions. I'm just... Yeah, everything I said in the past minute was just complete BS. Sorry, guys. But this tuple is very important, I think. Well, I don't know, but we don't have any other ideas. So I'm going to look at how it changes over time. And, yeah. So after the first move, we get that... We know that x2 is less than 2 to the n minus 1 because of the stuff we did here. Yeah, so that's always true. Yo, what's good, Abel George? Thanks for tuning in. x2 less than 2 minus 1. Okay, what about later? Ooh. So if we know that's true, hold on. Basically, we want, so for x1 plus x3 plus, can you show a problem you're solving? Yeah, sure. So this is the question 3 from the IMO today. Happened today. Question 3. Final question. So if we want to show that TS is always more than 2 to the n, it suffices to show that eventually, after the nth cut, x2 plus x4 plus x6 plus x8 equal to 2 to the n 2 to the n minus 1 plus 2 to the n minus 2 plus 2 to the n, so on, because that sum is 2 to the n minus 1, which would prove the problem. Now let me just zoom back in. Yeah, nice. I think we're very close. So if we can show that x2 plus x4 after the second move is less than 2 to the n minus 1 plus 2 to the n minus 2, then it seems like this is a good way, and we can probably induct on I, like the ith move for this claim. What A levels are you doing? Maths, further maths, physics, biology, and Mandarin. x2 plus x4 being less than this. Now, is that true for small cases? So, like, yeah, this is P3. 1, 2, 4. Oh. Okay. 1, 2, 4. So again, like x2 is less than 2, indeed. But now suppose that x2 plus x4 is more than 3. And hi, can you tell me how I solve it? I'm stuck in this. It's easier for you, but not for me. Maybe in a bit. X is less than or equal to 2. x2 plus x4 is more than 3. So x4 in particular is more than 1. That's the key here. And this is after, what do you call it? This is after just one cut, right? It's after just one cut. So, if it's after just, man. If x4 is 1, more than 1, then, well, we can go down. Yeah, let's do that. Let's go down. We know that x5 is not taken, and it is 1. We know that. x5 is not taken, and it is 1. So, x5, our boy, can, since there's only 5 pieces, right? Our guy can always be claimed, and that's a contradiction, because this means that x1 plus x3 plus x5 is more than or equal to x2 plus x4 plus 1, which very readily implies that this is more than 4 and this is less than 3. Okay. It seems like we're cooking on something. I think we're close. I know I've said that. After that question, gang, okay, you know what? After this question, man, I'm probably gonna fall asleep. But, I'll tell you what, you can go onto the, I made like a community post, go onto that, paste the question, and I'll get back to you like today evening or tomorrow. Yeah. But after I do this, I'm just going to sleep. What I predict day 2 is, man, I don't know. I just want to get through this question at this point. This question is frying me. Bro in the rain. Yeah. That is me. Okay. So we finally shown that 1, 2, 4 actually works. Now we just want we just want, what do you want, guys? We just want my days. Yeah, back to our original thing. So in general, we wanted, again, time for a break. How much battery am I on? I'm gonna run out soon. Better solve this. We just want this to be less than that. And so, yeah, this implies that x4 is more than this, very clearly. So everything before has been more. Which means that there are n cuts more than 2 to the... So we've had n cuts, actually. And everything is more than 2 to the n minus 2. Which means that the 2 to the n minus 2 has been untouched, I think. Has been... with the same age, and I am lacking. My days. Okay, so yeah, this implies that 2 to the n minus 2, 2 to the n minus 2 has been untouched. And yeah, so also x1 plus x2 plus x3 plus x4 is more than... Oh shit. Okay. So the key thing here, I think, is we want to suppose... So we want to prove by induction that this is true. And suppose that we have an element x2k that breaks it. Right? So the sum up to, this is not notation, by the way. That is, so this is more, which, and I need to go somewhere new, which in essence implies that x to the 2k is more than 2 to the n minus k. So everything has been more than 2 to the n minus k. And now, if 2 to the n minus k or any other smaller pieces have had a cut in them, then there would only be 2 to the k minus 2 possible pieces that have had a wait, hold on. Yeah. So there wouldn't be so like yeah, yeah. So we induct on k and then everything is more than this by the fact that it's decreasing. And what do we do here? We said that, okay, look, we got four pieces that are all larger than 2tn minus 2. So this 2tn minus 2 is not touched. Why? Well, if it were touched, then we would have not enough cuts to get it from the remaining pieces. So all the pieces that are, large enough, they're from the bigger ones. And it then follows, like, so the sum of xi from I equals 1 to 2k is more than or equal to 2 times the sum of x2i from I equals 2 to k, which is more than or equal to 2 to the n plus 2 to the n minus 1 plus 2 to the n minus k plus 1. And then, more than is strictly more than. More than or equal to, and this is strictly more than. Then we can add in the untouched pieces, and then to get that the total sum of the xi is more than 2 to the n plus 1 minus 1, which is a contradiction. Hence, the strategy always works even when we take k all the way down to n, and in essence, we have that x2 plus x4 all the way up to x2n is less than or equal to 2 to the n minus 1. And that's question 3 solved. 1, 2, 3, all done. Because for question 3, we had the strategy. We got it. Where is it? Where is it, man? Question 3, we had the strategy. And the bound up here. Oh my god, that's a lot of work. And that's the question done. And all 3 questions have been solved. And with that being said, I'm now gonna go to sleep. Thank you guys for sticking all the way to the end of the IMO 2026 Livesolve.